welcome to the Deep Dive. Today we're tackling something really interesting, how brain research, or cognitive neuroscience, as it's often called, fits into the world of educational psychology. You, our listener, pointed us to a fascinating paper from 1998 that dives right into this.
That's right. It's a paper called Does the Brain Have a Place in Educational Psychology by Richard E. Mayer, and it gives us a really valuable look back at how these two fields have interacted or, sometimes haven't over the years.
Exactly. So our mission here, our goal in this deep dive is to really unpack the arguments Mayer lays out. Like, why should we connect brain research to how we think about learning and teaching? And maybe why should we be a bit cautious? We want to see what this historical perspective can teach you.
Yeah, it's a great starting point.
Okay, so let's get into it. It seems this whole idea, linking our brains to how we learn, it's not exactly new, is it?
No, not at all. And that's one of the first things Mayer highlights. He points back to E.L. Thorndike, a huge figure in educational psychology way back, his 1926 textbook. It strongly argued that intellect, character, skills, all of it was fundamentally based in our neurons.
Wow, 1926. So you're saying, for you listening, this isn't some recent trend, it was there right at the start.
Absolutely central. Thorndike's connectionist theory, which was massively influential, was all about brain physiology. He saw learning as literally forming neural pathways, connections between situations and responses. He thought those were physical connections in the brain.
So not just abstract ideas.
Not at all. His textbook even had detailed drawings of neurons to really hammer the point home.
Huh. It's kind of hard to picture that in a modern ed psych textbook, right? Which I guess brings us to the present. Well, Mayer's present in 1998. Sounds like things had really changed by then.
Oh, dramatically. That's a key point Mayer makes. By the late 90s, talk about the brain had pretty much vanished from mainstream educational psychology. He gives some pretty stark examples.
Like what?
Well, take the 1996 Handbook of Educational Psychology. Huge reference work. You look in the index, no brain, no cognitive neuroscience, nothing.
Seriously, that seems significant, a big omission.
It really does. And it wasn't just the handbook. Mayer also mentions sampling articles from the main journal, the Journal of Educational Psychology, from 1990 to 97, found none with brain or cognitive neuroscience in the title or abstract.
Wow.
Yeah. And get this. The big AIR conference in 1997, over 1,000 sessions. Guess how many mention the brain?
Uh-oh. Not many.
One. Just one.
Over 1,000. Okay, yeah. So for you listening, that really paints a picture, doesn't it? A field that had sort of drifted away from its biological underpinnings.
Definitely. And even visually, like you said, compare Thorndike's neuron diagrams to the standard textbooks of the 90s. That biological grounding was gone.
So why?
Yeah.
Why the split? What was Mayer's take on why brain research fell out of favor?
Well, he suggests it wasn't always a smooth ride when people did try to apply brain stuff. He points back to Thorndike again. That connectionism, rooted in his brain ideas, led heavily towards, drill and practice, rote memorization methods.
Right, the stimulus response thing.
Yeah.
Just hammer it in.
Exactly. And maybe that wasn't always the best way to learn everything. Mayer points out it took educational psychology decades to really shift towards cognitive constructivist ideas, focusing on meaning, understanding.
And that shift, that revolution in the 60s, it wasn't driven by brain science.
That's the crucial point Mayer makes. It was driven by cognitive psychology, new ideas about how the mind processes information, not necessarily new discoveries about brain wiring itself, at least not directly influencing educational practice then.
So the field kind of corrected itself based on psychological insights, yeah. Okay, and here's where it gets tricky, right? Mayer also warned about, let's say, bad applications of brain science, even back in 98.
Oh, yeah. He brings up the classic right brain versus left brain thing, the creative types versus the logical types.
Of course. Still hear that sometimes.
Right. And Mayer uses it as a prime example of taking a tiny bit of neuroscience, oversimplifying it hugely, and turning it into these, often useless or even misleading educational fads. There wasn't strong science behind applying it that way.
So a cautionary tale for you listening?
Yeah.
Just because it sounds science-y and mentions the brain doesn't mean it's actually good educational advice.
Exactly. The link has to be solid, understood, not just like a buzzword. Mayer's core point here, and it's vital for you to get, is that just saying we should link brain research to education doesn't automatically make things better. It doesn't guarantee progress in theory or in the classroom.
Okay, so we see the history, the ups and downs, but what about the actual arguments for bringing the brain back into the picture? Mayer discusses these logical arguments from Burns and Fox.
Right. Burns and Fox laid out two main logical reasons. First, The argument from completeness. Basically, educational psychology can't be complete if it just ignores a whole relevant field like brain research, right?
Makes sense.
They argued understanding the brain could give us new ways to think about school tasks, maybe even spark totally new ideas about learning. It's like, you can't fully understand software without knowing something about the hardware it runs on. That's kind of the idea for you listening.
Okay, the completeness argument. What was the second one?
The argument from plausibility. This one's more fundamental. It says, look, thinking, learning, all that cognitive stuff, it happens in the brain. As they put it, software is coextensive with hardware, or cognition derives from neuronal activity.
So the mind and brain are linked.
Deeply linked. They even suggested that maybe the words psychologists use, like memory or attention, and the words neuroscientists use about brain regions or activity, might ultimately refer to the same underlying things, just at different levels.
Ah, interesting.
So the implication is, for any theory about learning and educational psychology to be plausible, to be believable, it needs to at least be consistent with what we know about how the brain actually works. It can't contradict basic brain function. For you, it's about making sure our models of learning don't fly in the face of biological reality.
That seems logical. But as you said, Mayer felt logic wasn't enough. He wanted evidence, right? Empirical proof.
Exactly. He respected the logic, but said, ultimately, it's the research findings, the empirical evidence, that will show whether bringing the brain in actually adds value. Does it really help us understand or improve education?
And Burns and Fox did try to provide some of that evidence in areas like attention, memory.
They did. For attention and memory, they pointed to studies showing different brain areas are active at different times during these tasks. They argued this supports the cognitive idea that these aren't single things, but complex processes involving different brain bits working together.
So the brain scans kind of backed up the cognitive models, gave them another layer of support.
Kind of, yeah. That was the argument. And for reading and arithmetic, they talked about brain injury studies. You know, when someone has damage to a specific area and then has trouble with reading in a certain way, or with math.
Lesion studies.
Right. These studies helped pinpoint brain regions linked to different types of dyslexia or math difficulties. And what Burns and Fox noted, which is interesting for you, is that there seemed to be some overlap between these neurologically identified problem areas and the specific cognitive skills or components that educational researchers had already figured were important for reading and math.
So the brain damage data lined up somewhat with a cognitive breakdown of skills.
That was the idea. It provided another type of evidence linking specific cognitive functions to specific brain locations.
Okay, so where did Mayer land on all this? He sees the logic, sees some early evidence. What was his overall assessment?
His view, back in '98, was cautious, but hopeful maybe. He felt the logical arguments were sound, but the real impact would depend on stronger empirical evidence accumulating over time. He did say that up to that point, the brain lesion studies had probably been the most useful source of information.
Because they show a more direct link. Damage here leads to problem there.
Exactly. It's a clear cause and effect, in a way, though obviously complex. But looking forward, Mayer saw three promising research paths. First, measuring brain activity during academic tasks.
Like scanning kids while they read or do math?
Basically, yeah, measuring those physiological correlates. But he stressed just knowing where activity happens isn't the main goal. The key, he thought, was understanding the function of those brain areas. What does that specific region do, and how does that function relate to the cognitive theory of, say, reading? For you, it's about connecting the where with the what and the how.
Got it. Not just brain mapping, but understanding the functional role.
Yeah.
What was the second path?
Analyzing brain activity during academic tasks into component processes. Trying to break down something like reading comprehension into smaller cognitive steps and seeing if different steps map onto different brain regions or patterns of activity.
So getting more detailed.
Yeah, trying to align the cognitive models of subprocesses with the brain activity. Again, the emphasis was on reconciling the cognitive description with the brain function description. For you, think of it as building a more detailed brain-based model of how specific learning happens.
Okay. And the third one?
Examining differences in brain activity between different types of learners. So compare brain activity during, say, a math task in students who are good at math versus students who struggle, or students with a specific learning disability versus those without.
Why is that helpful?
Well, Mayer argued the significance lies in understanding the function of the brain areas that show different activity patterns. It might give clues about the neural basis of learning differences, which down the line might help inform how we support different learners. For you, it's about potentially finding brain signatures related to specific learning profiles.
Right. So Mayer saw potential routes forward, but he also had some warnings, some important things to keep in mind.
Definitely. A big one was his call for a two-way street between cognitive neuroscience and educational psychology.
Meaning,
Meaning it shouldn't just be neuroscience telling education what to do. Educational psychology, with its understanding of real-world learning challenges, should be suggesting important questions for neuroscientists to investigate. And then neuroscience findings can feed back to help refine educational theories.
a partnership, not a dictatorship.
Exactly.
Yeah.
He contrasted it with a one-way street, neuroscience informs education only, or a dead-end street, they just ignore each other. For you, this idea of mutual influence is pretty key.
Makes sense. What else?
He also warned against the hype, being overly impressed by fancy brain imaging tech without strong theory behind the study. He really pushed for theory-driven research over just technology-driven research.
So the cool pictures aren't enough. You need a good reason for taking them and a solid way to interpret them. For you listening, the substance matters more than the shiny tools.
Precisely. And maybe his most crucial point for practical application. He stressed the difference between understanding how the brain works and knowing how best to teach.
That's a big one.
Yeah. Just knowing, say, the neural basis of memory doesn't automatically tell you the best classroom strategy to help kids remember things. There's a gap there that needs bridging with research that looks at both theory and effective practice. For you, it means we can't just jump straight from a brain scan to a lesson plan.
That translation piece is critical and maybe not always straightforward.
Not at all. So Mayer wrapped up by saying, look, cognitive neuroscience has exciting potential for educational psychology, but we need more really convincing examples of what it uniquely adds. He urged educational psychologists to think about how the brain constrains learning, and neuroscientists to tackle questions that actually matter for education.
A call for continued, but maybe more focused and integrated effort.
Yeah, pretty much. For you, it's about finding that sweet spot where the fields truly inform each other in meaningful ways.
Okay, let's try and summarize this deep dive for you. It's been really fascinating tracing this relationship from Thorndike's early brain focus through that period of separation Mayer described in the late 90s, and then looking at the arguments and evidence for bringing them back together.
Yeah, and the big takeaway from Mayer's 1998 perspective for you is really that caution is needed alongside the excitement. Understanding the brain is amazing, but applying it effectively to actually improve education. That needs careful thought, solid evidence, and moving way beyond those simplistic left brain, right brain kinds of ideas.
Absolutely. We need research that genuinely connects brain function to how we can best support learning in real classrooms. Which leads us with a final thought for you, our listener. This paper was from 1998. Think about all the advances in brain imaging in cognitive science since then. What do you think? Are the arguments for linking brain science and education stronger today or weaker?
And maybe think about specific challenges in education, like learning disabilities, attention difficulties, maybe even motivation. Where do you think insights from brain function could potentially make the biggest difference?
Definitely something to chew on. Thanks for diving deep with us.